Okay, let's go ahead and get started. Everybody, welcome to the call. We're going to go ahead and get started on the agenda. Let's see. The first item is testing. I think Dimitri might not be able to make it here. So what we'll do is we will start with Martin, who might have some updates on other types of testing.
Yes. So we've been doing we got the last fix merged into parity to run state tests on the fuzzers, and I've been doing about 500,000 fuzz tests since then during the last couple of days. We need to work a lot on improving the state test generator, but we have no blockers in terms of the engines and false positives. Yeah, that's about it for now.
Great. Okay, so next we have client updates. Let's just start with Geth.
I guess that will be me again because Peter is on trip somewhere. Yeah, we just made some maintenance releases, nothing really major to spend a lot of time on in this meeting.
Cool. Anybody from Parity here? Okay, I guess Alfrey couldn't make it. Let's go with Aleph.
Nothing important to mention. We have Constantinople ready for some time. I think that was already the case in the last meeting. And we're mostly working on some internal changes.
Cool. I don't think Piper's here for Trinity, so we'll go ahead and go to Ethereum J.
Hi, we were not working on anything except Constantinople. We have finished it, but have not finished tests for Constantinople. And that's all we are working on charging.
Cool. All right, Pantheon, if you have any updates or significant anything to talk about.
Yeah, so one significant update from us is that we're now syncing to the chain head of mainnet.
Congrats.
Yeah, thank you.
Cool. Anything else?
It's at DevCon, so you guys can check it out.
Great.
Yeah.
All right. Alexei, TurboGeth?
Yes, hello. So not much to report. I mean, you might have seen my latest blog post where I was saying about private beta. So essentially, we started working on some testing, which will include syncing to the main net and trying to do some performance tests with the RPC in Enfura. And I've been chasing some bugs, and but I wanted to, in terms of Constantinople, I noticed that there's a create 2 opcode where TurboGuest would need a special handling for that. And that's because something which a lot of people didn't realize, but I think it would be useful for people who are listening to this call to kind of think about it and to come up with their own scenarios, is that I think Martin has added some clarification to the IP that create 2 essentially allows you to, using the self-destruct, to basically replace the code in the contract in a certain way. By retaining the same address, but basically replacing the code, but losing the storage and the balance. And I think it's something which a lot of people don't realize. And then I would like everybody to kind of think about this and sort of give us a shout if anybody finds anything interesting or kind of potentially dangerous with that. Yeah, so that's my update.
Cool. Did you have something, Martin, to add?
Well, just that I think anyone who were present on the All Core Dev channel while we discussed the first iteration of Create 2 is already aware of this, but it's probably correct that it might not be understood in a general sense by the community.
I see. Okay. And we can bring this also back up during our Constantinople portion of the meeting if we want, if anyone wants Alexi or Martin to go into more detail about that potential pitfall. Next we have Nimbus. Is anyone here from there?
Yeah, Jacek, I'm around. So we've slowly been making our progress through the blocks, syncing and executing them through the EVM and hitting various kinds of bugs. I think we're up to 48,000 now or something. On the other side, we're working on F2.0. There's VM curves coming out. There's test serialization tests for the simple serialized that's being proposed. Yeah, that's it.
Cool, thank you. Do we have anyone from Ethereum JS? Do we have anyone from Mana? Okay, I think I got them all. Let me check and see. Do we have anyone from Nethermind? What about Ethereum? We have so many clients now, guys. This is great.
Yeah, I do. PyVM released a new alpha yesterday called Ada Lovelace, I believe. I don't know the actual particulars of that, but it's definitely getting to the point where if you want to pull it down and give it a shot, might be worth your time.
Yeah, I just downloaded it and started light syncing it right now, and it's already at 700K.
Nice. Okay, cool. I think that's all for the clients. We can go into eWASM now. Does anyone have an eWASM update?
Hey, Hudson, this is Lane. Yeah, we're very focused on testnet. So we did a public eWASM call earlier, geez, I don't know what day it is anymore, a few days ago. I think it was last week. And we did our first public demo of the testnet and the tooling we have around it. So we have a block explorer. We have this thing called eWASM Studio where people can deploy contracts written in WAST, which is WebAssembly text format. We have a few nodes up and running. It seems to be reasonably stable. You can connect to it using MetaMask. We have a faucet that's working, et cetera. So yeah, pretty exciting stuff. We're still ironing out some issues and bugs. We've had a couple forks on the testnet, improving the tooling. Yeah, and getting ready to release a bunch of documentation and stuff for DevCon. So look for that coming soon.
Great, thank you. Let's do research, starting with Casper and Danny, and then Vitalik with the rest.
Generally, on my front and E2O is clients are beginning to implement, and as we're doing that, we're sorting through subtle little bugs, and then in the spec, and also just beginning to come around on standards like networking and serialization, et cetera. Vitalik can take it from there.
Yeah, and so far the changes we've made to the Casper spec have been very small. I guess I'm figuring out trying to figure out if there's any basically.
Hey Vitalik, your connection's cutting up. We can hardly hear you.
Hold on a second. I can't tell if it's my browser or the PyVM doing it better now.
It's a little bit better now. It just kind of feels cut up and slow. But yeah, it might be your connection.
Still bad?
Oh, I can hear you now.
Okay, then it was probably my browser more than the PyVM. We're just trying to basically figure out what are the kind of attack vectors and centralization vectors and so forth. So at this point, spec-wise, it's definitely a sort of more verification than research already. And there's also a lot of work that's happening on the peer-to-peer protocol side, and that's honestly the thing that I'm probably continuing to be worried about more than the other parts. But even there's been a lot of progress. So I like at least my impression is that it's the protocol is increasingly the good kind of stable.
Agreed.
Great. Anything else? Sounds good. Okay. Next up, we have Constantinople. On the agenda item 4, you can click on it, and it shows the table of Constantinople progress. And Geth, Parity, Aleth, Ethereum J, Mana, and Nethermind have completed all of the implementation of the EIPs. Not all of them are compatible with actually testing them yet, but that's usually referenced either in the comments on that page or in the meta release issue that they have created. And then some of the ones who are still working on it, Trinity's almost done, and I'm still looking to see if Ethereum has some stuff going on. So yeah, that's kind of the update on the Constantinople for the client side. We should probably figure out a block number today, if possible, for the testnet hard fork. If not, we can do it on chat, but usually it's better to do it live because people can drag their feet. So does anyone have any suggestions? I kind of forgot the date that we had set up. Was it the 14th?
No, it was 9th of October.
9th of October. Okay. That is 1.5 weeks from now, roughly. How early do clients need to release and have the block number hard-coded in before it's kind of problematic to like really do something like release the day before? Is that something we need to watch out for?
I mean, it's Ropsten, which is mainly used by people who really want to run Ropsten, and I don't know if we need to take into consideration a really large window for people to update, do we?
I'd say no. I don't think we do. So
I mean, if it splits and we get the classic Ropsten and new Ropsten, it's not the end of the world.
Yeah, that's true. I'm thinking we could decide the block number a week before then. Does that sound crazy? I don't remember how we've done it before.
So the thing is, though, it would be nice to know the block number so we can include it in the next bi-weekly release, which is maybe before the next hard fork, before the next core dev call.
Okay. The next core dev call's on the 12th, I believe. So the fork or the testnet fork would be the 9th, which would be a few days before. I see. So when you do your bi-weekly release, when's the next release for Geth?
A bit less than 2 weeks from, well, 1.5 weeks, maybe.
Okay. So would it be before the 9th? Because if not, we can just push it a little bit and just have it on like the 12th or something like that. Because yeah.
It's not set in stone, really. Depends on other factors as well.
Okay.
I'm
Well,
just saying it would be. I think it would be nice if we could decide on a number for Ropsten today.
yeah, I'd love that. I think that'd be great. Is anyone at a place where they can kind of do a calculation on when the middle of the, like roughly the 9th of October when that block number would hit?
I'm trying to check the block time for Ropsten.
Thanks.
Yeah, I was looking at Etherscan. I don't think Etherscan actually publishes that information for Ropsten.
Let me check and see. Etherchain might. Oh no, they don't have Ropsten. No, I know Etherscan has the block time for Ropsten because, or I was pretty sure they do.
Oh, yeah, I think they do actually. I couldn't find a link, but if you go to ropsten.etherscan.io/chart/block time, it looks like it's just below 15 seconds right now.
Okay.
Around 14 seconds.
So how many seconds until the 9th of October?
I'm working on it.
Okay, sounds good, Lane. I was going to work on it too, but if you're doing it, that's
I can
great.
do it. I'll come back and sorry, I can't do that math in my head so quickly. It's 11 days. So that looks like around 1 million seconds, 950,000 seconds. Maybe someone could double check that.
Confirmed.
Yeah. And if we're looking at 14 seconds per block, that is 67,800, 68,000 blocks basically from now, which puts us at block, what are we at now? We are at block 4.131 million.
By the way, if you want to double check, then you can go to Wolfram Alpha and just type seconds until 9th of October midday or something. It gives you the 938,163 seconds.
Right. So there's a time zone thing as well. So
yeah.
If we want a clean number, assuming we can round slightly, I'm going to say 4.2 million. It's very close. I'm assuming we don't care if it's exactly on that day, but it should be.
Yeah, we just wanted around that day.
Yeah. So 4.2 million.
4.2 million?
Mm-hmm.
Okay.
I'm seeing 4199211, so I'm rounding up to 4.2 million.
Yeah. Anybody think that's a bad idea?
So what would be the estimate of the block 4.2 million then be? What time and day?
So that would be exactly 11 days from this moment. So that would be 10:30 in the morning Eastern time, whatever this is, UTC time on that day.
Which day is that? Is that a
Confirmed.
Tuesday?
4.2 looks reasonable to me too.
On October, which day was it that we said?
9th.
The 9th.
Yep, October 9th, like basically midday.
Midday on the 9th, 4.2 million. Okay. Sounds good. So I think we'll just go with that unless anyone has any other comments. Okay, great. So 4.2 million, midday, October 9th. Let me just write that down real quick.
Thanks for double checking my math there, Danny.
Yeah.
Thank you to Wolfram Alpha for double checking the math as well.
Nice.
I'll be impressed when we can directly type into Wolfram, what block number will Ropsten be on this date?
Yeah.
That'll be fun. Okay. Does anyone else have anything about Constantinople that they want to talk about?
Yes, I want to talk about Create 2 very quickly.
Oh, yeah, go ahead. Let's see if anyone else has comments on that after your discussion.
So I probably did not dial into the calls where it was originally discussed. So I've kind of discovered this a few days ago when I was thinking about updating Trooper Guest for the Constantinople. But essentially, because of the way that the contract address is calculated in the Create 2, which means it includes the MSG sender, some salt, and the hash of the init code. That actually means that as long as the init code and the salt and the MSG sender stays the same, you can basically redeploy the contract. So it only is going to work if you first self-destruct it, so it gets removed from the state, and then later on, it cannot happen in the same block, as Martin pointed out. So some later on, after you self-destructed it and then it goes deleted from the state, you can actually recreate it using the same init code. But if that init code actually loads the actual deployed code from somewhere else, then it adds a potential to actually instantiate the contract with a completely different code at the same address. However, the balance will be wiped out and the storage will be wiped out. So for a couple of things you can do with that is that you can upgrade the contract, but of course you have to think about the storage and the balance somehow, but also it allows you to basically very easily to clear out the large storage if you can't be bothered like doing a loop over the whole storage, and you can just self-destruct it and redeploy the same code kind of thing. But I'm sure that people, if they think about it, they can come up with all sorts of use cases for that. So that's what I was going to say.
Cool. Does anyone have any comments on that?
I have a question, and apologies if it's a slightly naive question, but like, to what extent is this possible today? Like, is any of what you're describing, can that be done with sort of current version of Ethereum? How much of a sort of precedent is there?
No, it cannot be done because there is a nonce. So in the case of if you create a contract from an external account, the nonce of your external account is included in the calculation of address. So you basically never generate the same contract address. And if the contract is created by the other contract, then the creator contract will also have a nonce, which will be included into calculation. So essentially, currently, whenever you create a contract, it will also always be unique address. But in the future, you will be able to create contracts with repeated addresses.
So yeah, technically, you're totally right. But like from a developer perspective, there are ways to achieve upgradability, and it's kind of a big thing that they've been working a lot on.
Like the way to kind of achieve equivalent functionality to what you would be able to do with Create 2 is if you use any kind of second layer registry. So like, for example, if the way that everyone accesses your contract is by accessing a certain ENS record, and then you self-destruct the contract and you create a new one. And like there's some way by which the new one takes ownership of the ENS record, then it'll like that basically gives you an upgrade. So there are ways to do this, but they're just like ugly and require you to do non-standard stuff.
Right, and another ugly way to do it today is using a delegate called proxy. So this basically offers a cleaner way to do it, and it obviously has drawbacks as well. It can be probably used for bad things.
And yes, and I also heard recently another thing about this delegate called proxy is that although it works really well to essentially proxify anything and the upgrades, but it does have although minimal kind of overhead, which it doesn't matter if you call it like a few thousand times, but if you start calling this thing million times, then overhead kind of adds up. The upgradability stuff from Create 2 has no overhead, obviously, because you completely replace the contract.
I just wonder if that's actually a feature, maybe we should considering make it more explicit. I mean, I just started thinking about that, but it's not so easy to do it this way because you need some additional contract, and I guess 2 of them actually.
Well, so that's why I wanted to bring it to the wider attention, because it has not been widely circulated. So it's something. At the moment it's like a quirk that only a few people know.
Yeah,
but I want to basically have to be known to the wider audience so that they can think about all sorts of ways that it could be used, and maybe like we get some new ideas out of that.
So I just wonder what would happen if we actually skip the init code, hash of init code. Would we become very bad, because that would like allow explicitly to do this replacement, and it might be if we will still have it as a feature, because that's how it will become if
The,
we
the, the, the main reason why init code has to be included is because if you do not want the upgradability, if your init code essentially is completely deterministic and it doesn't go anywhere else, then you will be able to prove your counterparty that what you're deploying at this address or not deploying, it will be exactly that code. So you say, okay, this is the init code which is completely deterministic, and therefore whatever is deployed at this address will be totally deterministic. And then you can open a state channel on that basis and do some sort of counterfactual stuff. So that's why the init code is important there.
Okay, thanks.
Any other comments? Okay. I think that's it for Constantinople, unless anyone has anything else. We'll go to the next item, which is item 5, EIP 1108, to reduce the alt_BN128 precompile gas cost. We had talked about this before, and we know we can't get it into Constantinople, but there were some new benchmarks ran by Antonio, so I'll just have him take it away with what he found.
Hey there. Yeah, it's actually one of our other developers at Deep Network who did the benchmarks, but basically one of the main concerns that came up when this was originally discussed was that the Go Ethereum performance improvements that EIP 1108 kind of based the new gas costs off of were not at all reflected in the parity client. So we ran some benchmarks because there has been some new code merged into Parity's BN library since then, and found a pretty large improvement in the performance of Parity as well. So we merged some adjustments to the EIP based on those improvements. They're still not quite as dramatic as the ones that we saw in Go Ethereum, but they're still fairly significant and pretty serious boost for SNARK and BLS verification work. So yeah, the new numbers in the EIP are based off of Parity's performance, which is slightly worse than Go Ethereum's, but still a big change. I think those are the highlights. Benchmarks are in the chat. They're also linked from the EIP now.
Awesome. Anybody have any comments on that or any questions?
Yes, I have some comments. So in the updated EAP, you recommend a lowering of EasyMull and EasyAdd, and also the pairing check. And for EasyAdd, you change it to 150, which, as I see, is quite well. It's higher than what the benchmark said. No? Okay, 126. I'm trying to compare it with the old ones for Geth here simultaneously. So for Geth, that would be a bit drastic, it looks like. Geth appears to be needing around slightly below 400. And for the Mull,
I'm likewise pulling the original Geth ones up as well. So yeah, I see the changes. Sorry, go ahead.
Yeah, do you have any, in the updated gas cost for the pairing check, what would your, the formula that you have in the EAP, what would that have been on the actual pairing check benchmark?
So the original EAP had 5,500K plus 80,000, which was aggressive, I think, even with your benchmarks for Geth. So what we did was look at the formula that came out of the benchmarks that you did in July, as well as the benchmarks that we did against parity, and kind of chose the higher formula that fell out of that, which was based on the parity numbers, which was 28,300K plus 35,450, which is the current version of the EIP. We also cranked up the EC add and EC null numbers from the original EIP to again reflect the higher of the benchmarks. Also worth mentioning that there's a contract call price for the precompile to keep in mind when we're looking at these gas costs.
Sorry, what was the last thing you said?
There's also the call price for the precompile that ends up being part of the gas cost for these guys.
True, but that really only matters for the modexp and the add, because in other cases it's only 700 compared to 40,000 for the multiplication. And for the pairing, currently it looks like with the latest optimizations, parity goes below, but not by a wide margin. Yeah, but these are great numbers. It was really nice to see that the progress that has been made. So yeah, looks awesome, and I'm hoping we can reduce it. But as I said, I don't think it's something for Constantinople.
The one note I wanted to make on that front, given the fact that these are relatively straightforward code changes that we're willing to put all our developers on to push forward, we do think that it's really important that these get in as soon as possible. And 9 months is a really long time to wait for the gas cost adjustments. So whether it's Constantinople, I know there's potential discussion of another hard fork shortly thereafter for Prague proof of work. It would be really, really nice if we could figure out a way to get what ends up being, I think, a config change for parity and a 40 to 50 line of code change for Go Ethereum in as soon as we can manage, whether that's Constantinople or something shortly thereafter. I leave up to y'all.
What are people's thoughts on that? Generally, at this point, I would say that, we've already decided what EIPs are going into Constantinople, etc. But I mean, if everyone really wants to put it in, that's obviously something we can consider. What are everyone's thoughts on that?
I think the biggest thing is always the testing. So it's the like, how is this going to be tested? And I would say that I would suggest that to work on this now, but just presume that Constantinople is going to happen as it is.
We are also willing to put legwork in on testing if that's helpful. So just throwing that out there.
Are there plans to evaluate any other clients according to these benchmarks on the subject of testing?
So yes and no. I mean, we know that the Python implementation, for example, will not, I mean, most clients will not be as fast as Geth or parity on these unless they link directly to some optimized C library and assembly code. So there's that. On the other hand, it's Geth and parity that's 99% of the mainnet. And I don't know if we should cater for every client, or at least those clients who wants to be on mainnet should be capable of linking to highly optimized libraries. That's my personal opinion.
Yeah, makes sense to me. But I was wondering if maybe Antonio was just saying that they'd be interested in doing all the requisite testing, and that maybe they'd also be interested in evaluating the performance of Pantheon.
Yeah, I think we can absolutely put in some legwork to do some additional benchmarks. I think we're getting good at it.
Sounds good. Maybe we could connect offline or something.
Yeah, sounds great.
Is there any C library that is optimized with the new code?
There is a C library that we have not had a chance to. We've done a little bit of work to try and see how we can integrate it into some of the other clients, including the Python-based ones and what have you. We're not quite there yet, so don't have anything to share quite yet. But once we've done a little bit of that work, I think we'd love to share it and see what others think of what's there. The specific library that we're using is MCL, and it is Harumi who created it. It's got support for quite a few different curves, but LBN 128 is one of them.
Okay. So yeah, I personally would be interested in, I don't know if you want to make it public or not, but I could replace this code, like the library Aleph is using currently with this new one, if that will help with testing and so on.
Yeah, we would love to help with that. I think from the perspective of getting the gas cost changes sooner rather than later, I do think that changing the underlying library in a client is probably a much more dangerous change than changing a few constants.
I agree with that. Yeah, I haven't I wasn't trying to make it a requirement. I just still find the C code to be it's the easiest accessible for languages like Python. I mean, I think we don't have good tooling yet for Rust, for example, to ship it to Python easily. That's why I'm asking, because I would be willing, if that library works and we can replace ours, I will be willing to add Python bindings to that as well, if that's something we want to have. But about the Constantinople, I'm rather in the direction that if any change is not ready at some point in time, it's just not included, and that's quite heavy pressure if we will keep at even small changes in the last minute. So I'm rather on this opinion that it should go to the next hard fork anyway.
Yeah, and regarding
I would say that any change should be first tested on a test network for at least a couple of months.
Yeah. Okay. Oh, Dimitri, welcome. I
Yeah.
didn't even see you come in here. So, Antonio, just to be clear, is your company Clearmatics?
No, we're Keep Network.
Keep Network. Okay, because I know Clearmatics also had a stake in getting these numbers changed at one point.
Yeah, they wrote some of the early blog posts kind of pulling through this, but we've been doing some of the legwork in actually getting the changes slotted in.
Cool. Well, I appreciate you being so forward in getting this done and dedicating some dev hours to it, and also being open to the fact that we might not be able to put it in sooner than later, but being respectful of that. So thank you and your team.
Thank you.
So anybody else have comments on that? Or Antonio, anything else? Anybody?
So I agree that, I mean, from the client perspective, this is a trivial change, but it means regenerating a lot of tests, and to do that, we need to do some work on the underlying test generator and stuff like that. And it's semi-manual work, which currently, unfortunately, we have not automated enough. So yeah, it's harder than it seems.
Yeah, for that particular change, I would also considering do additional fast testing of that. We did it before and we found some issues. I think that's kind of good opportunity to maybe to tweak the fast tester the way it will find long running executions.
Yeah, on my end, I think I've mostly already said everything that I have to say. Just that we do feel that the sooner the better on this. That 9 months is a pretty long time to wait for it, and that whatever we can offer, we'd love to do that. Whatever needs to be done to get that done sooner. So we do have a PR for Geth ready. We've looked into how to update it for parity. We've looked into some of the other clients and how we would do the updates there. So yeah.
So one thing though that we might want to look more into if we lower the gas cost is to find out, does our test vectors actually cover the worst case scenarios, or are there even worst case scenarios that numbers that causes even worse runtimes? And that's something I'm not sure it's fully covered. But right now we're very restricted with the gas costs, so it's probably not a denial of service vector anyway. But if we lower it to be closer to the limit, then we would need to spend some more time checking that, in my opinion.
I will give one other piece of context. There are certain BLS signature check operations and snark operations that currently can easily dominate a block, take an eighth, a quarter of a block. So that's kind of the numerical context for why we think this is so important. The current gas costs mean that doing even one of these operations is just a huge drag on the network.
Yeah, agreed. Okay. Thanks everybody for your comments on that. Let's go ahead to the next agenda item. That's ProgPow. There's been renewed interest in potentially getting it into a future hard fork, and I know that Paul has been working on some benchmarking. I think Martin worked on it and Geth a little bit, and I saw Offrey say that they were going to work on maybe getting something going in the Rust side of things. So let's reintroduce Miss If and Mr. Def. If y'all want to just give any updates on your side for ProgPow, and then we'll go over Paul and whoever else wants to kind of give their impressions based on their benchmarking. And if anyone has any questions for Miss If or Mr. Def, this would be a great time to bring them up if y'all have any questions on ProgPow. So we'll start with Miss If and then go Mr. Def.
Great. Put me on the spot, Hudson.
Yep.
Well, as the public knows, not much has changed. The C++ client is fully finished. The Geth client is almost finished. We had a CPU verification slowdown that is now being fixed. And that's really all there is to it. Once we see more interest from the Ethereum development community to adopt ProgPow, then we will have developers accordingly working on all clients. But until that time actually happens, I don't think it's worth wasting the man hours or the money to throw them at a project that most likely would just be ignored. So that's really my statement on the matter. However, I did have a wonderful meeting in person with Nick Johnson, and it's come to my attention that there is a lot of misinformation on how hardware actually works, on how ProgPow is tuned to hardware, and in general how the algorithm remains tuned to a GPU card and sort of balances out the efficiency difference between a GPU and an ASIC. And I believe that that misinformation is our fault as if def else, because as creators of the algorithm, we need to make sure that we're educating the entirety of the community and the development team on how it works. So I urge you all, if you have questions, very specific questions on how it works, now is the best possible time to ask. We're also available by email at any time. We will be making an appropriate Medium post along with the test results. The community has been doing wonderful testing on ProgPow. ProgPow is currently implemented into a coin. It's a very small, unnoticeable coin. It's called Bitcoin Interest, but many miners are happily mining ProgPow in a safe safe environment, production environment. I think that's really all on my end.
Great. And yeah, just real quick on my part, I have been with Powell communicating with some major, I guess, like major video card company kind of things, and looking into that a little bit more, and that's shown promise. We'll go next. Mr. Def, if you have any comments, otherwise we can go to questions after that.
I don't really have any additional comments.
Okay. Who wants to start talking about what they've explored ProgPow-wise, or any opinions on that? Powell, did you have anything you wanted to say? Or I think Martin also had looked into it a little bit.
Yeah, I have number of comments. So first of all, I must disagree with the statement that C++ client is almost ready already. So from the code perspective, I tried to use the library it's a fork of if-hash library, and there's number of issues with this change. And first of all, it's just replaced the if-hash with ProgPow. So that's not something we can merge because we need both of the algorithm side by side.
Are you talking about ProgHash on the Git?
Yes.
Oh, I was actually meaning the C++ Ethereum client. That one is what we've done, not ProgHash. Sorry.
So what do you mean by this C++?
ifdefl/C++ Ethereum. That was the one that we've completed. ProgHash was more for us to get familiar with the your implementation package, which yes needs to be revisited and addressed.
Okay, so I started with this one. So maybe I skipped that, and I couldn't get any benchmark from ProgHash. The only one I got yesterday, it took over 1 second to verify header. There must be something obviously not right. I didn't have time to check it on this level. And I started implementing some pieces of ProgPow myself just to be more familiar with that. And so it's possible I can finish myself this part. I haven't seen any pull request that was submitted to any project I maintained. So that's kind of a bit worrying. I'm not sure if you plan to submit some changes to any of the libraries, or we should take it ourselves.
We have been implementing them and just keeping it on our GitHub repo. We haven't done any pull requests. For sure, we can do that, but I think it would be better to work closely with the client developers, because as our Geth implementation has proven, obviously we are not masters in all these different languages. So we are going to need some assistance. Like, we have development force to basically do grunt work, but we're
okay. So Yeah, I'm not worried. Like it cannot be done, and definitely it's that is able to be implemented. So one more comment is about the IP itself. So there's so it's actually two comments. First of all, the official discussion board is Ethereum magicians, and I'm mostly posting questions there, and it's usually not very easy way to get response there. Maybe there's wrong way to go, but so in the IP there's many details that are not explained, and I mean it's not so difficult.
On which details, so that I can go and
It's like what pop count is and what CLZ is, and like so. I mean, for some people it's obvious what it should be, but I think we need a bit more details about how rotation works and so on. It's like if you can rotate by more than the size of that and something like that, the edge cases. So I mostly, to implement ProcPal, I have to actually go to some implementation you did to figure out some details, and EIP is not enough. I mean, it's definitely hard to get the implementation based on EIP only. And the last comment is about Keccak hash function. So I try to figure out what the parameters of that, and this is kind of exotic construction, let's say that way. And definitely, so I think if I calculated that correctly,
Are you talking about the 32/64 bit shift?
Yes, I mean I did before, but I already moved to the next item on my list.
Okay.
So so I'm talking about the Keccak hash function you used.
Yes.
And so it has permutation of size 800, which it's different from SHA-3, and so if I calculated correctly, the output in terms of security bits, some say it's 176. So this is much lower than the one a bit lower than the one we used. And,
yes.
And more to that, it's only 64 bits taken from that anyway. I don't have any crypto background in cryptographic background, but I want to ask if that is any concern in terms of security and
yeah, I have it's a little public that my identity now and what kind of background I do have in cryptography, but no, it's not a security concern. The specific change from F1600 to F800 was simply because GPUs, they're natively the 32-bit architecture, and F1600 is just twice as long on a GPU. And that actually gives you a nice little speed up with ASICs. Whereas we don't require, we can't consume all of those bits very efficiently. So just reduce the size. It doesn't decrease your security at all. And we can go, actually it's quite public. I can elaborate on that on the EIP. That's a very good point. There's been a public study on F1600 versus F800.
So yeah, I'm not worrying about the permutation size.
Okay.
I'm a bit worried about the bit rate, what is called there, right? It's quite high comparing to the permutation size, because so yeah, that's only I can say about that from my perspective.
Okay. Yep.
An explanation of that, and also there's no padding to this hash function at all. I mean, so
yep. We
this
can
is
detail that.
This question is put also in this Ethereum magician board, So if you can explain that one, I will happy to have it as a part of EIP.
Sure.
Cool. All right. So yeah, so that sounds good. Does anyone else have comments?
Yeah, so I can add a bit. I have not gone into the same detail as Pavel, but what I've done is I've taken it and implemented it for GEF and done some benchmarks and see how it integrates. Yes, and it turns out it's a very, very simple change, and the verification time about doubles, which is not a big problem in my opinion. So the other day I mined a bit on the CPU, and even on the lowest difficulty, I did a chain which switches over from Hashimoto to ProgPow at block 5, and it takes about a couple of minutes to mine. The first 5 blocks is just keeps on ticking very quickly, and then they start coming to ProgPow, and it takes a couple of minutes to mine each block. So that's at the lowest difficulty. Which is just an observation, and it doesn't really matter, probably, other than for generating test chain stuff. So I would have liked to generate a long chain which has multiple epochs. It turns out that's quite difficult to do. From a testing perspective, I have the feeling that for testing this, we really shouldn't and cannot use the regular testing infrastructure, because this has nothing to do with the EVM semantics. This has nothing to do with the block rewards and the uncles and what have you. This is the only thing that's needed for testing are snippets of chains, and the only quirky behavior is if there's at the switchover block, a ProgPow block has uncles which have Hashimoto style proof of work and stuff like that. So I think that, I really think this change could be implemented in parallel with Constantinople. And from technical perspective, they have nothing to do with each other. From a political point of view, yes, they might be very related. That's about what I had to add. And I can add also that if the technical underpinnings are there, that Powell thinks this is good, and that people who are in the know deems this to be ASIC resistant, then I think it's a very good change, and I'm for including it as soon as possible.
On the implementation side, Martin, are you able to give us, you mentioned something about the epoch. Right now you prefer to have it, you'd prefer to generate a very, very long chain. Is that correct? Would you like us to make a test vector implementation of that?
Yes, please. So that would be minimum 30,000 blocks.
Yeah. So by just to make sure everyone understands, by implementation, in the implementation, ProgPow is meant to change every 25 blocks. This is actually very hard to do because you need a sort of a bridge between the miner and the pool, which would be some sort of stratum implementation. So instead, the next easiest thing to chain it to is per epoch. So this is why it does that, but obviously it's not very nice for testing. So we can do a test implementation where you can just keep chaining it, but it would definitely don't put that in a production environment. Simply because...
Sorry, I'm not sure if we understood each other. So what I was talking about was a sequence of blocks, RLP encoded blocks that are... Was that what you meant also?
Yes.
Yeah.
Okay, that's noted. I'll have someone work on that this week.
Thank you.
And did we got it down to 9 milliseconds as well. Any assistance with other optimizations that folks might see would be very, very helpful, because it is meant to be 8 milliseconds in theory. It's just that Go isn't our strongest language on the development team. So.
Yeah, I mean, I don't think. Yeah, I'm sure it can be lowered. It can probably be lowered a lot with assembly, but I think the most interesting thing to do is to make sure that all the things that Powell has listed that are required for Propo adoption, that those things are implemented, so that there is support in the mining protocols and the mining software and what have you.
Yep, where I've noted those down, and most of those are either clarity needed in the EIP, clarity needed in the code, and more public reference. So, and also checking the bitrate size versus permutation size and padding, etc. So all of that's been noted and will be done. That's really good feedback. Thank you so much, guys.
Yeah, thanks for coming on and answering some of these questions. Do we have other feedback or questions?
Yeah, I have two more comments. I think Martin meant, so I listed, some time ago, I listed list of changes that are, in my opinion, required to do the switch. And I will try to find it just in a second. So it's something that is outside of the ProcPal implementation itself. So in my opinion, we had to propose also a Stratum protocol that would include information of the algorithm is supposed to be used for miners, because there's no information about that there at the moment.
I posted the link there in the chat.
Okay, great. Yeah. So yeah, I don't remember. I think that's the biggest one, and that can be started work on very soon, because it's nothing related even to client implementations. And I might find some people that willing to work on this. So I plan to propose EIP describing this protocol and implement that in if miner on the client side. I'm not sure about like on the mining pool side if there's a chance someone will adopt that, but I think AIP is good starting point for it anyway. Yeah, there was some other changes that, I mean, maybe I'm wrong about some of that. So please take a look there as well. Leave some comments and yeah. And one more thing. So I have some struggle with commenting, especially this level of complicated EIP as ProcPal, because it's not in any kind of review mode anymore. It's merged as a draft, and there is no way to leave a comment at a particular point in the EIP to address some issue. I think it would be much easier to put discussion about single line, instead of having that very much separated on some other media. So that's, I think, as a group, we might considering maybe there's a way to improve that process. For small IPs, I think it works because there's not a lot of lines to comment about. But in this one, I would really like to just pin some comment in particular point to make it also much easier to address by the author.
I think that, yeah, I understand your concern there, and that could be a consideration for changing the EIP process in the future. But I think the reason that we have it the way we do is that you can have multiple discussion links. So on the EIP, if they wanted to add a GitHub repo that had the most updated EIP that was outside of the main EIP repo that you could comment on line by line as it's being iterated, that would be a solution, I believe. So we would have both the Ethereum Magicians link as the discussion link, and then also a link to a repo that they maintain that you can line by line comment on the EIP and any other implementation in that repo. So I think that would probably be a good idea. And I think Miss If has to go. Who was that? Yeah, we can definitely bug Mr. Def. Okay, goodbye, Miss If.
I have two. Can I have two comments as well on this topic?
Absolutely, Alexi.
That's Alexi. So first of all, I did look at the Go Ethereum code when I think it was Martin's pull request, and I think when it was reported, it was 80 millisecond verification time, and I tried to optimize it, and there was actually the gist attached to that pull request, which contains some optimizations, which mostly is like about avoiding extra allocations and copying things around, but realized that these optimizations actually don't make any difference, because the biggest cost is simply the access to this data item. And then later on, I think the change was made to reduce number of accesses. Right. So, and the second comment I have is that I think that we need a bit more exposition about why. I mean, we kind of believe that this is, from reading from the description of the algorithm, that it's supposed to be doing what it's doing, like getting it harder to implement an ASICs. And I get the general idea, but I do believe that if people do really know what's the reason, they can actually explain it in some simple way. Maybe not in a very simple way, but at the moment, I feel like a lot of people, including me, either I'm really kind of dumb, or I'm just kind of don't really know what I'm doing. I'm just trusting that somebody else who is cleverer than me kind of understands this, but I don't. And I also got some like people privately talking to each other, or something that they can't disclose, and it just doesn't have a good feeling. So maybe somebody can down. I mean, I know it takes some effort. Write down some exposition about why exactly the current technology of ASICs will not be able to do this thing efficiently in a more detailed way, so that like people can apply the critical thinking rather than just trusting that somebody is, somebody says that they have experience, and then they just said, okay, that will be fine. That's my comment.
Hey, Alexi, I think that's totally fair. It would be helpful to get specific questions on areas where you want more information, and I think we have been very bad about handling the Ethereum Magicians discussion, and so we will improve that in the future and be a little bit more responsive. In terms of why this algorithm is ASIC resistant, I think we should all start from the point that the algorithm's goal is not exactly to be ASIC resistant. I mean, GPUs, we started from this discussion, or the effort, from the perspective that GPUs are ASICs, right? And we're actually designing not to be ASIC resistant, but actually to be friendly, or to be very much tied to a single type of ASIC, which is a GPU. And so that's the perspective that we started with. And so in optimizing for a specific type of hardware, the goal is to maximally utilize all the functions of that hardware, right? A large register space, that's expensive, and of course not to forget the starting point of why ETH hash is strong, which is it's still memory bound, right? So the algorithm starts from a place where it's memory bound, and it's still going to be predominantly memory bound. And in addition, also has to use also has to use the additional register space from required that that GPUs are able to provide and are needed for additional math calculations. And on top of that, adds the programmability aspect, or the programmatic aspect, which is the exact math series of math operations that you're running is changing in every epoch, or actually if proposed with the Stratum implementation, would change every 25 blocks or 50 blocks or something like that, to change even faster. Now, when you do something like that, the problem with implementing an ASIC for something like that, or a different ASIC or more custom ASIC, would be that you would have to design the ASIC to either be flexible enough to capture all the possible variations or evolutions of the algorithm, right? Or you'd actually have to have an ASIC that already designs for every variation or every kind of math ordering in kind of this evolving algorithm, right? So if you pre-design for every possible variation, well, your ASIC just explodes. You're just burning silicon area that's mostly unused. And if you try to design for the programmability and the register space that you would, or the register file size that you would need, then you basically have something that is a very big ASIC that is also applicable to many other general math problems, right? Which is fine, because if you're going to design a general math processor, I think that's the goal of this project, right? I think having more general math processors in the world is a good thing, and having these more flexible computation units is a good thing, at least until we have proof of stake. So leveraging off of an existing install base of more general math units was the goal of this project. And that's the standpoint, right? So we're basically trying to force, say, a custom design to be not that custom, right? Because you have to be flexible to varying and changing math at a very rapid pace, and you have enough variation that you can't pre-design for all of it, and you have to pay additional silicon, right, to capture, to be able to even execute the math. And that was quite simply the goal. Now, if you have specific implementation questions in terms of why ASICs can't keep up with it, or it can't design for these math variations, we can certainly do deep dive on this. And I think our responses, or question responses, it would probably be best to put it on some public forum like Ethereum Magicians, so that once you've asked a question, it's a very valid one, that everyone can see the response, and we can just point people to that forum if other people have similar questions.
And I know that Miss If also mentioned that you all are doing a Medium post that might answer some more of these questions and make sure that people understand why it's certain types of ASIC resistant.
Right. And to be clear on another point, it's not that a GPU is. We tried to make a GPU as optimized as we could, make the algorithm as optimized as we could for the GPU. But it is true when you see some statements that it is not the most optimized piece of hardware, simply because things like GPUs have floating point paths that's not really appropriate for cryptography. But that's only a small part of the silicon that's unused. There's other parts of the silicon, including display outputs and things like that, that of course is also unused. And in working and having the GPU makers assess and review this algorithm, the conclusion was that it's roughly 20% of the area would be unused, and it's not would not be a 20% power penalty, but simply a 20% area penalty, or basically an area savings that you could have if you stripped out all the unnecessary bits of a GPU. And then we also asked them to do an economic analysis of what that savings would be in terms of having an ASIC be more economically efficient in saving that silicon area. And we did basically, there's online, you can go look at basically die area assessments of how much it would cost. And if you look at GPUs that are most popular in the mining world today, I guess that's the 480 or 580, and then maybe some of the GP106, GP104 silicon, then it's roughly $50–$60 for a piece of silicon, and then you save roughly 20% of that, which is $10. And for the total manufacturing cost of the board, that's roughly $200. You're really saving an insignificant amount of the total cost of the board. So yes, the ASICs, you can have a more custom hardware design for ProgPow than GPUs and save some silicon area, but economically speaking, it's not a significant impact to the economics where it would cause someone to go do a custom design, especially given the amount of volumes that GPU manufacturers have access to, versus someone who would be doing custom design. The costs just would not be, the economic structure of doing an ASIC just would not be worth it. Now, there's also been other comments that we've seen where GPUs are moving further away from doing simple math, and that might be true. But at least in this generation, until we get to proof of stake, I think this is a reasonable kind of interim for proof of work before proof of stake comes in.
Cool. Good commentary. Alexei, did that kind of meet some of your concerns, and you all can come up on Ethereum magicians and all that?
Yes, I mean, I did read most of the things that were said. Actually, I read on the GitHub, which is fine. It's now I kind of understand that you're do two things. You're optimizing for the GPU, and then you're introducing some of the things that are harder for ASICs. I kind of get it. So what I would like is to have this. When you said that we talked to the GPU manufacturer and we asked them to do this and that, is this information somehow available or not?
Say again. The information somehow available.
So when you said that you asked some of the GPU manufacturers some questions about how much it's going to cost to do this, or like how much of the GPU area will be used by this algorithm, like, is this some kind of documentation or just some sort of chats that you had with some people?
Yeah, so we reached out to the manufacturers based on the connections we had. I don't think this is public information. However,
right.
They advised that there are some very good reverse engineering analysis already, existing technical analysis of this generation of silicon. I think for the generation of silicon I referred to, let me go try to dig that up and see if I can point those out. I think in general, I would suspect that GPU manufacturers would not be that excited about doing exact detailed area analyses because they have competitive concerns about doing exact breakdowns. But and that's why we ended up with a hand wavy rough estimate.
Okay, so what I would suggest, if it's possible at all, I know I've done some the GPU programming myself a few years ago, so I know that when you run some algorithm, you can actually kind of profile it so that it tells you like how much the bandwidth you have consumed and how many registered you've used and all sorts of this, how much of the, these operations and that operation. It would be useful if you have access, if you can run that and then basically just have some data to demonstrate that this algorithm is actually utilizing these resources on a GPU, like let's say that utilizing, let's say 90% of bandwidth.
Yeah,
or
that's a very
is
good
it
point.
possible?
Yeah, it's possible. I think that's a wonderful suggestion. Let me get on that, and we'll have somebody put that
Thank
together.
you very much. Yeah, thank you.
Awesome. We have a few more minutes. Lane, did you have anything?
Oh, just super quick. I know that you said that you and Pavel have been in touch with some like GPU manufacturers. Did I understand that correctly? You said earlier on the call.
Yeah. So right now we're keeping those conversations private just because we want to respect the privacy of the manufacturers we're talking to. But yes.
Sure. Yeah, I was just wondering if this hasn't already been part of that conversation, but maybe just getting some confirmation of some of the same ideas that Mr. Deff has shared with us here would be helpful.
Absolutely. That's exactly why we're talking to them, so we can come on one of the next calls and say we've confirmed what they're saying with the manufacturers.
Awesome.
Cool. So we have a couple minutes left. I want to give the last 2 minutes to Dimitri to give the testing updates, and then we can end the call. Mr. Deff, thank you so much for joining and providing some clarifications.
Sure. May I hop off now?
Yeah, absolutely.
Thanks. Bye-bye.
Bye. All right, Dimitri, go through real quick on any testing updates, and then we'll be done.
Oh, okay. I've been mostly refilling all of the tests with recent changes from CVP test ETH. So state tests are done. For Constantinople, it's generated VM tests are updated. I'm changing the way the hash of the test is calculated. So that's why all of the tests are now refilled with different hash. And I'm trying to fix a Python script on a test repository to match this hash check. And I'm currently working on blockchain test regeneration. I would like to keep some of the blockchain tests being mined with ETH proof of work. That's because there are some interesting cases where blocks have uncles, where blocks have many different uncles, or there are many blocks. So I would like to keep those tests with proof of work just to see how difficulty is generated. And one of the interesting features of the blockchain test that I could deliberately change some parameters of the blocks. So there are some tests where blocks are getting in different timestamp shift, whether it is forward or backwards in time. And there are some interesting cases with the difficulty checks that are in a blockchain test is this way. So if we are to implement a new way of mining, I think there are some changes to be done to blockchain tests on an interface level, because I would like to manually set which blocks should be mined with a new difficulty algorithm and with the old one. And currently,
there's no change to the difficulty algorithm.
Yes, so this progressive proof of work is not happening in Constantinople. That's correct?
That is correct.
Yes, that's nice, but I think eventually we will implement something like different proof of work. So I will work on towards that direction. Refilling blockchain test takes a lot of time if it has mining. And I have to fix a CPP client. There are some errors happening when mining or when refilling the tests. It takes some time to understand what's been changed in CVP and how it affects the test generation. Well, yeah, it will take some time for me to regenerate all of the blockchain tests. But overall, it's going fine.
So, Dmitry, when you said the state tests were done, are they merged or are they in a PR?
So let me think about that. I think I could not merge this PR until I fix the Python script in test repo, so it shows green. and I kind of stuck because of the YAML test at the moment. I remember Hyperman suggested some help with Python validation of the JSON hash. So I would appreciate that. Well, I could disable this hash check for YAML for now, and I could merge those tests if it's necessary to do it in the near future. But you could as well just pull from the pull request and see how Hive is working.
Are there any other comments? Okay. Thanks everybody for showing up. We will talk to you all in 2 weeks after the hard fork on testnet.
Sounds good. Thank you, Hudson.
Bye-bye.
Goodbye.
Bye-bye.